So having seen the power of ArcGIS as a mapping platform, now let's take a look at ArcGIS as a spatial analysis and data science platform. As you can see here, a data science workflow typically starts with data engineering, where you transform your data, you extract, prepare, cleanse, and enrich your data. ArcGIS helps you create analysis-ready data easily. And then you might visualize and explore the data itself for what it has and what it doesn't. You may then run analysis, and then the location-enabled data could be used from within Python or R for scripting, and finally arrive at the most valuable aspect of your workflow, which is turning your answers into actions as you share and collaborate. ArcGIS integrates all types of data and helps you organize them as geographic information assets, like maps, scenes, and layers, which can then be used for your analytic workflows and for dissemination. This year, we are excited to highlight our recent work with multidimensional raster data and even unstructured data, and then going beyond that into LiDAR data and full motion video. We want to help you unlock the full potential of your data. To help you transform this data into action, ArcGIS integrates open experiences, our R integration and our ArcGIS Bridge, two examples, and then the Python API with ArcPy and the ArcGIS API for Python, integrated with Python notebooks. And then the open scientific libraries and APIs and tools, such as TensorFlow, Keras, PyTorch for machine learning, or Pandas and NumPy for data wrangling. Let me share 3 new features that recently appeared in the ArcGIS Bridge. The first one is your ability to connect with either online or enterprise to access portal items, like feature layers, and use them. The second one is through Articulate, being able to reticulate, to be able to access ArcPy and to call into geoprocessing tools, all from within your R environment. And the third one we're excited to share is integration with notebooks through Conda. The platform has a comprehensive set of analytic methods and spatial algorithms designed to scale and perform to meet your needs. It could be interactive spatial analysis. It could be calling asynchronous geoprocessing tools. It could be spatiotemporal analysis on observation data. Or it could be real-time streaming analysis done through scripted processing, where you're pipelining your workflows, where you bring multiple analytic methods together. We continue to make giant strides in trying to make spatial analysis approachable as developers, as users, and as partners. Last year at the Dev Summit, we introduced ArcGIS Notebooks as a very familiar and collaborative experience for data scientists within any organization. Today, we are glad to show how much more is possible as we've unified and integrated this across the platform. To get started, I'd like to introduce Ankita from the ArcGIS Spatial Analysis team to show us what's possible with Pro. Pro is a powerful spatial data science workstation with advanced analysis tools and APIs to access at your fingertips, literally. Ankita, take it away.
Thanks, Jay. ArcGIS Pro has always been a powerful data science workstation with thousands of out-of-the-box analysis capabilities. But today, I'm going to show you how we have enhanced the data science experience for our Python user community. Using the CDC data and a machine learning algorithm called random forest, I modeled the percentage of population with chronic kidney disease in the state of Alabama. One potential way to reduce the cost and improve the efficiency of providing services is to create balanced administrative zones. To do this analysis, for all you Python developers, let me introduce you to Jupyter notebooks that are now integrated into ArcGIS Pro. Let's start writing this notebook. Using a markdown cell, I can give my notebook a meaningful title. Next, I can import ArcGIS and other environment settings to have consistent analysis results. Next, let's create 20 zones for the input chronic kidney disease data by balancing the number of patients, income, and distances to dialysis centers. Within ArcGIS, I can access the new Build Balance Zones tool and its documentation. But since this notebook is integrated into ArcGIS Pro, I can leverage the UI to copy the tool's Python signature. Let's run this analysis, and while the tool is running a machine learning technique called genetic algorithm to create balanced zones, let's add more information, such as an image, to make this notebook more informative. The tool just finished running and added the results to my map with the desired symbology and the associated charts showing the distribution of number of patients in each zone. These charts not only interact with the map, but also these selections are honored in the subsequent analysis in my notebook. For example, this dissolve function dissolved the selected zone and created the zone's administrative boundary. This map, chart, and notebook interactivity wouldn't have been possible in standalone Jupyter notebooks. These notebooks not only seamlessly integrate with ArcGIS elements, but also easily integrate with open source libraries, such as my favorite, Pandas and Seaborn. Using this notebook, I'll analyze peaceful and violent protests in India since 2016. I converted my feature class to a Pandas data frame. And using Pandas' convenient API for time, I extracted years from my date string. Next, to visualize the protest events in space and in time, I used Seaborn's violin plot. After data exploration, I'll run the new co-location analysis tool available in ArcGIS, which uses a spatial statistical method to examine if peaceful protests are significantly co-located with violent demonstrations, not only in space, but also in time. The output of my analysis gave me these dark brown locations where these two types of conflicts are significantly co-located, concentrating near the capital and the border of the country. Finally, I documented my workflow and analysis results for better reproducibility and shareability. With these new interactive ArcGIS notebooks, we can't wait to see how you leverage them in your daily data science workflows. Thank you.